I'd like to welcome everybody along to the October meeting. We are getting towards the end of the year, and tonight we have a special guest from Rocket Lab. Dr. Sandy Tirtey will be talking about the progress that Rocket Lab has had over the last 12 months, which is quite significant. And we're really looking forward to finding out a bit more about what their plans are in the next 12 months based on the current progress. Thank you very much, Sandy, for joining us.
You're very welcome. Can you see my presentation slides?
Yes, we can. It looks good.
Okay. I apologize. They are a few months old. Actually, they are from March. A lot of the things are still relevant, so that's no problem. But the number of launch will be off simply because the presentations I gave lately were sometimes very short for panels, so they would not have been suitable. But that will still be the right basis for discussion. All right. So, well, first at a glance. So, as I said, it's a bit old. So we had 23 launch back in March. Now we are at 31. So we've significantly cranked up the cadence, and we having another one in preparation very soon. We have a rocket that also has arrived in Virginia, and another one is on its way to Virginia. So we are pushing very strongly to fly from the US before the end of the year. It's been a pretty hard road, simply because our rocket flies with a flight termination system that needs to be certified by NASA, which means NASA has to deliver a piece of software, and NASA has been dropping the ball for 2 years. So we're waiting for them, but we have a rocket there ready to go and trying to put pressure for them to really deliver the piece of software. Sorry, that's my dogs in the background. Number of satellites deployed. Now we are up to 151. So that's significantly increased as well. We still have 3 launch pads. We're still the second most frequently launched rocket in the US. We have 3 mission centers now. My wife is walking behind to let the dogs out, and she was trying to sneak underneath. So all right. So we've done 4 strategic acquisitions, which I'm going to talk at length in the second part of my presentation. Sorry, we have built 2 factories. Actually, we are building the third one. We have 3 of our own satellites on orbit. We've recovered 3 rockets now. I'm going to talk more about it as well. And we have significantly more than 3 interplanetary missions scheduled. So we've been quite busy. And it's actually interesting also for me to look back in March and look where we are now, which is only 6 months later, and see that everything has significantly changed. So first of all, Electron. So back in when we announced it back in 2014, we were the very first one to build a rocket fully made of carbon with 3D printed engine and battery powered. Now it sounds like 3D printing engine is the normal thing to do. Back at the time, nobody would do it. Everyone thought actually that was not possible. And the fully carbon rocket as well, simply because it's very hard to make it compatible with cryogenic liquids. I think we can say that Electron has been a successful vehicle, and with our new vehicle, Neutron, which I'm going to talk about in a second, we are basically trying to follow up and reuse the similar technologies. We are very vertically integrated, so we try to do basically as much as we can ourselves or in-house. So we have multiple locations in the US, in California, in Virginia. We have Sinclair Interplanetary in Toronto. We also have now somewhere in New Mexico and in Colorado. We are based in Auckland. We also fly from Mahia, and I'm based actually in Brisbane. We haven't put it on the map. So we have a lot of facility and people in different places. I think last time I've done this talk, we would probably have been in the order of maybe 400. Now we are 1,400. So we've increased a lot. So the way we divide our work is the engines and the avionics are produced in California. The body of the rocket are produced in Oakland. The entire stages are assembled in Oakland. The rocket engines are individually tested in Oakland as well. Then we test an entire stage 1 or an entire stage 2 on a stand. That's number 7, also in Oakland. And then we fly either from Mahia or from the US. I think I can skip this. Basically, we started our project in 2014, so we are now well, that's going to be my 9 years at Rocket Lab. When I joined, we were 7. Now we are 1,400. So it's been quite a journey. So really, the reason we've designed Electron was to design a vehicle able to provide a dedicated ride for a small satellite. So that was to be the taxi or the Uber, whatever we want to call it, of small satellites. So they don't have to always be on a ride share. A lot of other companies picked up on this idea as well over the years. Now we have, I think we've counted 150 companies claiming to want to do this. We were the first one to achieve this in 2017. Virgin achieved this, I think, 2 years ago. And Astra achieved it, I think, 2.5 years ago, 3 years ago, maybe. We still remain the only ones to have a product. The reason I'm saying this is all these companies are focused on doing the first launch or having the second launch or the third launch. But they all still trying to build a manifest by highly discounted launches and basically subventioning launches. So they sell the launches at a large loss. Sometimes they charge a third or a quarter of the price just to try to have a bit of a manifest. We have been making profits on our launches since 2019. So the last 25 missions have been really full commercial missions where we had the margin, but where also we had a very clear schedule from the moment we signed and have delivered on schedule. This is very, very difficult to do. You need to really be in control of your processes, of your costs. But yeah, I think that's been a pretty successful story for us. We are still working very hard on just increasing the cadence and basically repeatability. And one of the reasons it's been so hard is that the rocket has been evolving a lot. The very first rocket, I think, could launch 130 kilo. Now these days we launched 200 kilo. But for example, for our mission to the moon, that was a different trajectory, but we launched a payload of 300 kilo. And that was a highly modified rocket. There was not even a camera on board because we could not spare the mass of a camera. So there's been a lot of development, and we are finally settling on a final product. And I think we will stop really doing development of Electron, and we will focus all our development on Neutron. But coming back to Electron, really the focus was launch on demand, frequent launch, and be able to offer a customized orbit. These were only the first 18 launches. We are up to 31 now, so we can actually fill the screen. So commercially, we are the second most, not actually only commercially, we are the second most launched rocket in the US, and the fourth most launched worldwide. And this is considering China and Russia first, where they are mostly a government launch. So we're doing quite well, I think. Half of our customers are commercial, half are government. It would be about 30% defense, 20% civil. So when I say government, so far it's been exclusively US government. However, we're opening to Australian government, we're opening to other governments. Commercially, it's been really payloads from a bit all over really. We've actually had a lot of successes in Japan with quite a few commercial launches from Japan. We try to maintain a state-of-the-art manufacturing. When I say we try, the reason it is difficult is that you don't want to automate too early, because if something keeps changing or may change, automating is actually losing time and money compared to doing manually. So we've been really strategic about the way we were automating things, and now that we increase the repeatability of the rockets, we are increasing what we can automate. But we've tried very strategically to not be ahead of our development and ahead of the market. We have a high launch availability. From Mahia, we can launch every 3 days. We have now 2 pads in Mahia, which means that we can do operation on maintenance on one pad and launch on the other pad, or conduct, for example, a wet dress on one while the other one is in final state of preparation, or this kind of thing. And we also have our pad in Virginia, which we've done a wet dress rehearsal on, but we're waiting for our first launch, hopefully by the end of the year, if we can get that the piece of software from NASA. I'll spend a bit of time on this. So reusability is very important for us, and the way we do our reusability is quite different from Falcon 9. So we don't do a propulsive landing. Instead, we reorient the 3rd stage. So that in itself was a big process. A lot of the attitude control system that were on the 2nd stage had to be duplicated on the 1st stage. So after separation of the 1st stage, the 2nd stage can basically reorient and be ready to enter the atmosphere with engines first. We have a controlled re-entry. We deploy a supersonic parachute and then a subsonic parachute. And the way we do our reusability is that we have a helicopter that come and catch our parachute in flight. So our rocket never touched the water. This has been a difficult process in New Zealand because we could not actually find a helicopter in the country that was big enough. So we had to buy one. We had to get it from overseas during COVID, so that this has been a difficult thing. Back in May, we were finally ready to go. We've actually caught the parachute. Unfortunately, the pilot decided to eject. That was his first time, of course, and he was not really used to the way it feels to have a rocket stage attached to your helicopter. So he thought that there was something wrong, new helicopter, new pilot as well. He felt that he was being pulled down, and that was simply the mass of the 2nd stage and a slight mismatch of vertical speed. So we are extremely hopeful and quietly confident that our next recovery flight, which is coming in a few weeks, should be successful. At least we hope. So although Electron has been quite successful, for us this is just the beginning. Electron is great for one-off or two-off. For the company's perspective, for example, we've launched 4 of the satellites now. But you can't really deploy an entire constellation or mega constellation on Electron, simply because it's going to take a lot of time and probably cost a lot of money. It's like sending all the passengers of a bus one by taxi. So we've recognized that we need also to develop a larger vehicle, which is dedicated to constellations. So the same clients that we've launched 1 or 2 times in Electron now would be launched by batch on the orbit they desire. So this is the size, sorry, of the fairing for Electron. So for Neutron. So the Neutron launch vehicle is a reusable vehicle. We do the reusability by a propulsive landing, so a bit similar to Falcon 9, except that our baseline is instead of landing downstream, landing downrange on a barge, we boost it back to the launch location. The idea is that you save cost by not having to operate maritime assets that are expensive, and you increase the frequency, and you increase the reliability by not having all this transport operations. So in return to launch site, Neutron can deliver 8 tons to low Earth orbit. If there is a client that has significantly more demand and that we need to do a downrange landing, Neutron can then deliver 15 tons. So this is a large vehicle. So as I said, it's designed for mega constellation, national security payloads, and also we're rating it for human spaceflight. So being able to deliver astronauts to the space station or low Earth orbit. The second stage is expandable. We designed the second stage to be as cheap as possible, as light as possible, and the first stage lands. We also keep the fairing captive in order to be able to reuse the fairing. All right, so one thing on which we've been particularly busy over the last 3 years now has been space systems. So when I last did a presentation with you guys, we were a launch company. But our goal had always been to be a space infrastructure company. And people who want to do space application typically start with the application and then realize that they need satellites. So they contract a satellite company, and the satellite company contract launch vehicles. Typically, they try to save as much as they can on the launch. The launch get delayed, they get delayed, and you end up launching one by one. And this is taking a long time. This is what I see for nearly all my clients. The company that I know that doesn't do that is SpaceX. They started with the launch vehicle, and when they decided to deploy Starlink, OneWeb had started way before them, and SpaceX beat them by a long shot, simply because they had a launch vehicle and they had full control on being able to deploy the asset to orbit. So we're on a similar trajectory. We have a launch vehicle. We're deploying another launch vehicle. When Electron put a satellite in space, our third stage has a propulsion system, has avionics, has a guidance navigation system, has an attitude control system, has a telemetry, all the telemetry system. So it's not far from being a satellite. Just add solar panels, add some radiation hardened avionics, some reaction wheels, and you have at least the hardware of a satellite. So basically, we decided that every single time we launch a client, we potentially have a satellite for free, and we could offer a different version of our third stage when it's simply deploying a satellite, or where it could be the bus of a satellite, so satellite system. So our client would basically bring on the payload, the experiment, and we would provide the bus. Or we could use our third stage, which is now a satellite, as a space tech, basically, as a vehicle, orbital transport vehicle. So this is something in which we strongly invested over the last 3 years. It's exactly what I discussed. So we launched our very first PHOTON satellite, I believe, back in 2019. And the goal was really to demonstrate that it was working, to build our skills, but also to have our satellite now on orbit and basically build the orbital time on it, just to demonstrate its lifetime on orbit. So that PHOTON was called First Light. It is still on orbit today. We're still talking to it every day. It had countless versions of flight software, which we keep maturing, and our team had a lot of training on it on how to control and operate a satellite in orbit. Shortly after this, we won the Capstone mission for NASA, where we were supposed to deliver the Capstone CubeSat on an orbit where it would get into lunar orbit. So we've built another of our own satellite called PHOTON, which is a pathfinder for Capstone. It flew, I think, in beginning of 2020, if I remember well. And the third satellite we launched is this one. This is Capstone. Capstone flew in June and has successfully injected the NASA Capstone satellite on the translunar orbit. This was a tremendously complex mission, since in order to minimize the size of the satellite, we didn't have a direct injection to the moon like you would do on the Apollo program, but it was basically a trajectory that was optimized for requiring as this propellant and as this delta V as possible. So we would first go on the low Earth orbit, and then every time we cross the right plane and the perigee, we would do a boost to raise our apogee. So we've done apogee raising maneuvers over a bit more than a week. I think 11 burn or something like this, until we left the Earth attraction, the Earth orbit, and we've placed the Capstone satellite on the translunar orbit, and then we separated the Capstone satellite. By that time, our job was done, and we did a few more experiments on our Capstone platform. For this, we had to develop many things. We had to develop a new version of the engine, a hypergolic version. We had to develop many components for our Photon platform, including larger reaction wheel, including a radio system that allows us to do the telemetry, but also the navigation. So this was a pretty, and we've also had to increase strongly the performance of Electron. So this was a very important mission to us, and it's been a very successful mission. Capstone is still on its way to the moon and should arrive mid-November, sorry. It is now operated by ESI, which is actually one of the companies that Rocket Lab has acquired. But the satellite, the Capstone satellite itself, was not built by Rocket Lab, and it's a NASA satellite. So in terms of launching, our reliability or responsibility is done, but we're still operating the satellite itself. This was the first mission of the NASA Artemis program. Our satellite backlog has increased a lot since this slide was made in March. So instead of 8, now we are at 27. And within this 27, a lot of the satellites are different. So we had Capstone, we had PHOTON, we had first light. So these are the first two slides. MethaneSat is a satellite that is not built by Rocket Lab, but will be operated by Rocket Lab. This is a project from the New Zealand government, which is going to observe the Earth and observe all the methane emissions. This is basically a mission that will be used, the data will be used to shame the governments that emit a lot of global warming gas. The ESCAPADE mission, Rocket Lab is building 2 satellites that will be delivered by Falcon 9. Will be launched by Falcon 9, and these 2 satellites will be on their way to Mars and will enter into a Mars orbit. VADA, this company has bought 3 satellites from us, 3 Photon satellites. That company makes on-orbit manufacturing, so they will manufacture some item, and then this capsule will re-enter the Earth's atmosphere and deliver these items. We've announced that we finance our own mission to Venus. So the same platform as the Capstone platform will deliver a re-entry vehicle in the Venus atmosphere. This is a mission that is purely funded by Rocket Lab. And we have another instrument on board which is going to take some chemical measurement of the high clouds of Venus. The reason is that it is believed that there could be some evidence of molecules that are produced by life in the high clouds of Venus. So it was close to our CEO's heart, Peter Beck, that if one day is in a position to potentially do a major contribution to science, that he would give it a go. So this is why we're fully financing this mission. LOGSAT is a mission where this is a NASA satellite, and we demonstrate how to operate a cryogenic tank, liquid oxygen tank in orbit. And finally, so this is 8 missions, and finally there is 27 to 19. So we will manufacture and deliver 19 missions. Sorry, because NADA has had 3, so 17 missions for a company which I forgot the name of, but this will be for telecommunication platform. So as you can see, very quickly, PHOTON in just a couple of years has become a brand name, a collection of components. So for example, we have 3 propulsion systems. We have 5 or 6 size of reaction wheel. We've acquired the company SolarAero, which makes exquisite solar panels. They make the solar panels of the James Webb Telescope, the solar panels of the helicopter that is now on Mars. So we're providing solar panels to many companies. We are providing flight software. We are providing star tracker, separation system. So we have all this collection of components that can be used to many missions. And so now we have interplanetary missions. We have a telecommunication platform. We have Earth observation platform. We have a Mars observation platform. We have a re-entry capsule. We have a low Earth propellant management platform. So it's a lot of diversity of satellite, and we keep adding to it. This is the typical collection of components that we are providing. So Rocket Lab also is selling components to satellites. And Peter Beck's goal is that there's not a satellite taking off without at least one Rocket Lab component inside. So I think, considering all the satellites that have components have been manufactured by Rocket Lab or by a company owned by Rocket Lab, we are up to 1,500 satellites. This little news where latest in March, but not anymore. So we've opened a second path. And this is the company I was talking about. So we've been selected by MDA to design and build a spacecraft for the global star constellation. I have a few backup slides, but I don't think you'll learn much more. These are more of the components. This is PHOTON. This is another view of the capstone platform. This is the NASA ESCAPADE mission. So the goal of the ESCAPADE mission is to some measurement, I think, of the magnetic field of Mars, the structure of composition, variability, and dynamics of Mars' unique hybrid magnetosphere. This is our mission to Venus. What I explained before. Yeah, this is the end of my slide. I'm trying to think if there are some other notable things that we've announced recently. So we've started building a large production complex in Virginia for producing neutron. We've announced the engine that will be powering neutron, which will be a liquid methane and liquid oxygen engine produced in the US. That is called Archimedes. And I think that's about it. So thank you for your attention.
Thanks very much, Sandy. I just thought turn it over to everyone else for asking questions. I actually had one question myself, was to do with the neutron timetable. It wasn't really quite clear as to how many years that will take. Obviously, you don't have an engine at the moment, or you're still developing it. So what was I know it says 2050, that's probably how long you're considering it potentially or being used for, but what's the development schedule? About 5 years, or was it shorter than that?
We're targeting end of 2024. I'd say realistically beginning of 2025.
Oh, okay.
So some components of the engine have already been built and are being tested. We've signed an agreement with NASA Stennis to use the facility for testing the engine, so we don't have to, the problem of what we do is that you don't just build a rocket. You want to build a rocket, but there's no components that are acceptable. So you now get in the business of building valve, building regulators, building all these things, and then you also need to build a test stand. So there's a lot of civil engineering. Then you need to build a pad, and then if you want to fly a vehicle like NEUTRON, which we don't plan to do at the moment in New Zealand, well, New Zealand doesn't produce enough liquid oxygen to even fill the tanks once. So now you would have to build a massive propellant plant. So this is a difficulty, is that a rocket is a high tech piece of equipment, and therefore you need all these other technologies to support it. So by setting up ourselves somewhere like Virginia, launching from the US, where we can find large production of propellants, we're going to launch first from the ex-Antares launch pad. So there is a launch pad now that can take the mass of NEUTRON. In using the test stands, then we don't have to build a test stand. So we try to get there as quickly as possible by having the right collaborations. But yeah, end of 2024, beginning of 2025. And we've announced this. I think we've said it publicly, but probably not a lot. But this was before Amazon announced that they were buying so much launch capability from SpaceX, from Ariane, and from ELA. The beauty about this is that it means that when NEUTRON come into service, similar class vehicle will be extremely busy for quite a few years. So there's a big dip of launch availability at this time, in this timing. So that sounds like a good timing.
Yeah, actually, that leads into my second question. I'll just get that one quickly before I turn it over. The facility at Virginia does sound like it's quite important, which you've already mentioned that you feel that that's going to be the future of the capabilities that Virginia has got. I think as a spaceport is it has a lot of those cryogenic capabilities and things like that, which probably would cause you some problems over in New Zealand. So realistically, trying to get that commissioned over there to work properly is very important for your long-term plans.
Absolutely. And, you could fly from the Cape, you could fly from Vandenberg, you can obviously we'll be flying with Virginia. The advantage is that Virginia has the most launch availability. The Cape is very busy, Vandenberg is very busy. We're receiving the most amount of support there. So we wanted. It's been great to fly from New Zealand. It's on own launch site, full launch availability. So this is something that we don't really want to give up on. So we feel that Virginia offers us at least, when you have a new launch vehicle and working your process, and sometimes when you think will take 5 days, take 6, it's very good to have a range that is very available. So this is why this was the first site that was selected. Constellation is our main, sort of our first target, but we will also be targeting GEO and GTO. And so when we do that, having something closer to the equator will be interesting. So again, we may very well fly from the Cape as well, but we'll see. Right now, that is not our main objective.
Yeah, longer term in the Cape, we don't really know how many players are going to be there, and obviously the Cape's got a lot of pads available, but you'd have to then obviously customize it. But if you're already working on something in Virginia, there is other companies operating from Virginia as well, so you wouldn't be the only one that's got there. So it's good move for that. Other questions?
Every pad is always customized anyway.
Yes, yeah, I know that's true. So it's a matter of how many free pads there happens to be. That's right. Okay,
Exactly.
so other questions, please?
Lou's been waiting.
Sorry, Lou. I
Yes,
didn't-
I don't know.
Oh, that's right. So Anne asked the question, we're in Virginia, Wallops Island, which I think is the, I think that would be where I'm expecting it to be, but we might be wrong, of course.
That's correct. That's correct. And our production facility is just outside of the NASA Wallops site, which means that you know, if another company is launching from Wallops, you can't enter the perimeter. So by sitting just outside, that allows us to have obviously full access to our facility, while other operations are going on at the Wallops launch site.
Question, what were you going to ask us?
Me?
Yeah.
My turn? Yeah. Okay. I'm just curious about regulation. It must have been lots and lots and lots of companies like yourself, like independent, launching satellites and into orbit and probes out to places like Venus and that. What regulation? International? Is there an international body you make application if you want to launch a satellite? You know that you have to go approval, and then like the orbits you send it into. Are there international bodies that you have to do that to? Or that doesn't concern you, the person who wants to?
No, it does. So we fly under an FAA license. So we are considered as a US launch vehicle, and our launch pad in New Zealand is under an FAA license.
Okay.
When a client, let's say an Australian client, want to fly with us, they will submit the application to the FAA, to the New Zealand Space Agency, and to the Australian Space Agency. Now, it's the same information. So it doesn't mean doing the same work 3 times, but they will all review it. They have slightly different interests. So the FAA is going to be really the main one that is going to make sure that this is all safe, and check who we are launching and to what orbit. The New Zealand Space Agency really cares a lot about orbital debris. So what is our plan for that? And the satellite is operated by the client. It's their responsibility, but all the rest, basically, when are they going to re-enter the atmosphere? And if it's an Australian client, Australia would look into this, but would also look at the insurance aspect. If we're launching an Australian satellite and there is a failure and some damage is caused to a third party, Australia would be responsible for the satellite itself, and so our client would need to take an insurance. We are insured. Our client needs to have an insurance as well that covers a certain amount.
There must be lots and lots internationally now of independent players like yourself. Roughly how many do you think? Thousands, or
how many launch sites?
Like independent rocket launchers like you, satellite launchers, people who make your own independent rockets. How many do you think worldwide, roughly, sort of?
No, there's very few.
There's quite a few, hundreds, thousands, do you think, at this stage?
No. very little.
Very few, very okay. That's all. I don't know. My ignorance.
So look, I can't speak for the Russian rockets and Chinese rockets because they're basically government rockets. But if I talk about the commercial operators, which commercial operators are now up and running? There is SpaceX, there is us, there is ELA, there is Ariane, there is Virgin, and there is Firefly had a successful launch, and Astra, and that's it.
That's all there is, and that's the point that is interesting, because I would suspect that Rocket Lab is probably now having more launches than Arianespace. And it's got Arianespace's life got more complicated because they've changed.
Yeah, definitely.
And the fact that they were now then offering Russian launch vehicles, which is suddenly stopped, which means that now they have to go back to the Ariane 6 launch vehicle only because they can't do the other launches at all because of the embargo. So they've actually lost some capacity to launch at the moment. So that's put them in some difficult positions, I suspect, with some clients.
We still also remain the only commercial launch site in the world. There's a lot of companies declaring to want to do what we do. We've counted 150. It's extremely difficult to get there. It costs a lot of investment, and that can skyrocket easily. For us, it cost us, I think, about 150 million to have this vehicle totally up and running. It cost about that 10 times that to Virgin. So there's a lot of investment. It's a very hard road, and you can fail at any time. We've seen a lot of companies going bankrupt. We're seeing a lot that are not going well. I mean, now that we're a public company, Virgin and Astra are also public companies. We all publish our quarterly results. If you look at Virgin and Astra, the finance is not going very well. So it's very hard to get there, and it's very hard to stay there. The market is growing. It's not big, and SpaceX has created a few years ago a rideshare program to try to undercut the market. So SpaceX is flying the transporter missions, and we recalculate at every mission how much revenue they get, and they lose money every time they do transporter. But this is not the reason they do transporter. They do transporter mission to try to suck the air out of the room for companies like us, because they realize that a lot of companies starting like us are employing SpaceX employees, and so they try to kill the competition before it exists. Fortunately, we got there. Well, we managed to go there no matter what, and we rely mostly on dedicated launches, which is something that SpaceX cannot offer on a much larger vehicle.
Yeah, so it's actually quite an achievement. You're talking about the fact that you've been able to at least feel you've been able to break even or make a profit since 2019 on the actual launches, which is one of the big problems that some of the smaller players have, because they deliberately try to keep their costs low, but then they're making a loss. They can't keep doing that all the time without eventually running out of money. So that's the problem.
If you look at our financial return, on those, it looks like we're not breaking even. It looks like we're still slightly negative. But this is because since 2019, we had huge investment. You've seen in our satellite program and now.
Yes, that's right. You've invested in operations.
Exactly. The Electron vehicle itself, since mission 5 or 6, has been flying at cost or with profit. Simply because the contrary is not sustainable.
Yeah, that's really the main thing to note, is if you've got a combination of both, longer term, the company's going to be viable, because I mean, a lot of people talk about what the hell's Blue Origin doing, but at the moment they've got nothing that's launching except for that, and that they don't really have an orbital launch vehicle, and they've got engines. So at least you're in a position where you've got one launch vehicle, and they're developing a second one, and people have got confidence that you're able to launch, and you've also got the capability with the control systems and stuff like that you're doing more manufacturing. I'm assuming that that's partly why your workforce has increased, because some of that is you've ramped up your manufacturing capabilities at the same time as that's partly what the growth has come from, I'm assuming. So that's a good thing.
Manufacturing and also satellite division.
Yeah. Yeah, well, that's true. The satellite division in itself would amount to control people and things like that in that particular area. So it's a good choice for it. Okay. Have you got any other questions?
Yes, I've got one, if I may.
Okay.
Sure.
Okay. Great talk. Thanks. Your Venus slide shows you using a hyperbolic trajectory from Earth to Venus. That's much more energy expensive than a simple textbook Hoffman. Is there some reason for that?
I know very well what a Hoffman transfer is, but I don't really know why this is hyperbolic trajectory. I actually have not heard of a hyperbolic trajectory. orbital mechanics is not my first training, so no, I don't really know, to be honest.
So we might
do you know the difference between a hyperbolic trajectory
Yeah,
and a Hoffman transfer?
This Venus 2023 slide, the second bullet point says hyperbolic trajectory with high energy photon as the cruise stage and as a communications relay. Hyperbolic trajectories are very expensive in the planners.
Yeah, so no, I'm just saying that I don't know what a hyperbolic trajectory is compared to a Hoffman transfer.
Okay, no worries.
But do you know I was just wondering, do you know the difference? Because I'd love to, I'd love to know.
Oh, okay. Yeah, obviously from a physics perspective, it must be a lot more energy. So that's probably what Ian's concern would be, is that the transfer itself. But going back to the capstone mission, that was actually quite an achievement. The fact that you were able to get the launch vehicle into lunar orbit by just raising it progressively. That's always been some people talk about the opposite effect, like how to decrease orbits, but how to increase. In this particular case, I don't think there's too many times that's actually happened for a launch vehicle, unless they're running basically ion propulsion. And I don't think that was ion propulsion, was it, that you raised that out?
No, it was hyperbolic. And I have to admit, it was a bit stressful because the very first time we used that engine on orbit, we have to light it 10 times or 11 times.
Yeah, that doesn't happen very many times with that type of propulsion systems. That number of restarts, you know, even in the Artemis, that's only got to have one restart, and having to do it so many times and successfully do it is a good of a testament, really, to be able to the fact that you're able to do it. But the only thing I can think about the slow orbit raising is really ion, and generally speaking, that's just continuous. So I can't think of anything that's really happened like that before. So that's an interesting thing that you could potentially do in future if you really had to, by the sound of it, with that vehicle. But obviously it's got its own concerns there, really. Okay.
I know that shortly after we separated the capstone mission had a bit of an issue. It was no longer our satellite, but it has then been recovered, and now it's in good health.
Yeah, I heard something about some control problems that they've been having with it, but it's not your launch vehicle that's got anything to do with it now. It's just to do with the way that they're running the guidance on it, and it has got ion propulsion, I believe, on that once it's getting closer to the moon anyway. What they're trying to test out is a particular halo orbit that NASA wants to use for the gateway, and getting there's a bit of fun.
The latest news is that they're back in full control of it. So,
yeah, that was what I found that out yesterday too. I was just looking at what was happening with the mission, and they mentioned that they'd finally got it back in control. But it sounds like it's a very slow process. I mean, you've launched it a few months back now. Was it June? Was it? That's right. So we're now up to October, and it is obviously taking a while to get there anyway. Even though you've got it out of orbit, it's got to go into a really special orbit. And there's some issues about getting it there properly and controlling it. So NASA's trying to learn how to do this, because I don't think this has ever happened before, really, in terms of an orbit. So that they're testing out basically how they're going to put the gateway together, so to speak, with Artemis. Whether they can do the same thing, really. Okay.
So it should get there in 1 month, hopefully. Mission.
Yes, it's nearly there. It's nearly there by the sound of it, which is great. Okay, so have we got any further questions then for Sandy? Okay, well, I'd like to thank you very much, Sandy, for making the time to talk to us again. And it's interesting to see how the company's progressed in the last 18 months. There's a lot happening, as you can see, and I can tell you'd be very busy. I suppose COVID did have an impact on things initially, but now things are a bit more normal in the last 12 months. It does mean life is a little bit easier in terms of moving things around with people and probably equipment. So that's one thing that has allowed you to be able to ramp up your activities.
Yeah, I'm being sent everywhere in the world.
Yes, that's right. You weren't stuck in Australia. That's right, over there, or possibly even going to New Zealand. It was a lot, but given the fact that you got a lot happening next year by by the plans that you've got, you're going to be quite busy in the next 12 months. So thanks for making the time to talk to us.
Oh, yeah, you're very welcome.
Okay, thanks.